Okay, so he's just reading what I have on the board. So let me just put something always on the board for you to see. Okay. So microphone on. Okay, so. Okay, so like as I was saying, this is what you find is not that it's so easy to confuse. All right. We did area calculation by coordinates. That's the last topic we dealt with. And you realize that for that one, you need the distance and ordinates of every single point. Okay, so three from points A, B, C. Are you getting that? All right. Then we actually generalize this. That if this point represents I, so then we could actually write a formula that connects this point with the next one. So we use EI plus 1 and but you know that this is the second control. Are you okay? All right. So there are different ways of calculating, but what is the limitation to this one? Using coordinates. What's the limitation to using coordinates? So what are the assumptions? The assumptions for using coordinates to calculate this. What are the assumptions? Function. What are the assumptions? So you need to look at it like an example. So understand that this calculating this area was important. What are the challenges? What do you need to get the work done? Are you okay? At every workplace, you ask yourself, what do I need to work today? What do you need to use the area calculation by coordinates? Today's lecture is not interactive, so don't be quiet. It's okay. What do you need? This is the kind of question that is a very good question. Okay. See, you can't answer it. Can you see that? Very simple. Very simple question. What do you need to use the formula that which is coordinates? What do you need? What is required to calculate the area of a P and the area, okay, based on coordinates? What is required? So if I took you right now to a site, what is the challenge? All of you are thinking we are not surveyors. In this class, you're a surveyor. And if you don't behave like one, you fail. You come again and do it. Are you okay? What would you need? What would you be saying to whoever puts you in charge of that project? That you are asking me to calculate the area. Are you okay? What I'm used to is dividing the area up into squares like multiply length times breadth. Are you okay? Well, I'm a basic student, I'm a science student, but at least I know the area. I split it up. Yes, I'm triangles. I work out the area. I add these pieces together, isn't it? But that's fine. It doesn't always work. It's not convenient always. Are you okay? All right. So there are different ways that we want to calculate area. And you said that we can make use of coordinates at the vertices of the shape of interest. Are you okay? So the question is not really a good one. Let me just say, I shouldn't be asking the question. You need coordinates, don't you? All right. What is the challenge? What do you need to get coordinates? So you need to do a traverse. Okay, the requirement for this course, I was told that you should have learned these things already. So don't cut it. It's okay, don't think, that lecture, this one, it doesn't work that way. They are linked. You need to do a traverse, which allows you to determine the coordinates of the unknown points. It's okay, by measuring angles and then distances from known points and then computing the coordinates of the unknown points. Is that okay? So you work out the change in easting and the change in northern, and then you add them to the coordinates that you know. Are you on the same page? Okay. All right. So unless you carry out a traverse, you can't. What's the other way of getting coordinates? By using global positioning system, which we are going to talk about briefly, maybe in the next 2 lectures or so. Is all. If not next week, maybe it's all right. That GPS allows you to get coordinates. It's all right. So what I'm trying to say is that the method determines, are you okay, or you need to, depending on what you have, the equipment that you have, the method you're applying, you choose a particular method. Are we good? Okay, right. Okay, so we can have, there's another method that can be used that we want to look at. So this one is a trapezoidal rule. Okay, so a trapezoidal rule, you have an area. So let's assume this area. We want to is that okay? So you subdivide the area into an even number of strips. Is that okay? So just, but then you have a constant interval. So just say that. And so every single interval here you can refer to as x. Let's call this. So we have to get x, j is x. So x is an interval. Okay. Then we have the offsets. We have this offset. So for every single one of these offsets, there's a distance of what x. Are you getting that? And you have an even number of these strips. So how many is it? We have an even number of these offsets or odd if the strips are even. No, this one is lottery. Is that okay? You need to just give one answer, other odd or even. So you can try a luck, or you can actually be scientific. Is that okay? So give an answer and justify it. If I have an even number of strips, guys, how was it this class? You are in charge. Yeah, I have an even number of strips. How many offsets do I have? In reality, how many offsets do I have? To have an even number of strips. Okay, how many offsets do I have? Do I have an even number of offsets or and why? Okay, let's start with this basic one. If I have this, how many strips do I have? Give a strip, go to the hospital and give a plaster. Plaster is like a strip. Are you okay? Go to an airport, see the runway is like a strip. Is okay? Right? So a strip is like it's an even number. It's not a strip. That's a strip. Alright, so how many strips do you have here? Yeah, even, isn't it? How many offsets do I have? 2. How many offsets do I have? How many offsets do I have? Okay, so pi. Right, I don't have to ask you. Is that okay? Alright, I just have this one, and that one. Have 3 offsets. So in other words, I write the relation between the number of offsets and the number of strips. Is that okay? Right? So what's the formula between the number of strips and the number of offsets? Number of strips is equal to number of offsets minus 1, isn't it? Plus or minus 1. No, but obviously we all know that the difference is 1. Right? Plus 1. That's it. All right. So to calculate the area, I just make use of the formula. Area equals to x. So x is an interval over 2. So O is the offsets. O stands for offsets. So O1 plus, so O1 is the first offset, then 2O2, okay, 2O3 up to 7. Okay, so what's the interpretation of this? That's what the student need to know. Okay, so if you get to an example like this, you're going to take this diagram, directly relate to it, and defend it to measure that this is it. I understand. Are you okay? I know exactly how to apply. All right. So what you see in there, so 2 times the second offset plus 2 times the third offset up to the last offset. Are you okay? So do we see any trend in there? What's a trend? All right. Can we generalize it? We can just say that the intermediate offsets times 2, isn't it? So if you keep going, we'll have something like x on 2O1 plus 2 out 1 2 plus 4. All these are the offsets plus 7. Okay. isn't it?
So,
All right. Second.
so what if the offset distance is 5? You have to.
Okay, so it's like I said, I like to look at this from a story point of view. So that's why we start with this is the main story. Always understand that it's the first offset, it's the second offset, third one. Are you okay? This is the first one, that's the last one, this is the intermediate offset. Okay? So 2 times my intermediate offset, isn't it? Last first offset, last offset. Now what's my interval? This should be called, should say as that throughout this is a large area. X. So X will be like 1 meter or 10 meter, depending on what you are. So you see, your question should be answered somehow. You should just answer by what I just said. What if you have what? Okay, what's the question?
I want to understand the 7.
The 7 is the last offset. So the first. Okay.
So it's because of the brackets.
How many brackets do you have? 1, 2, 3, 4. So yeah. What's
So,
what's
I think the bracket is not okay.
Mm.
So say the last.
Okay, they are dots here. Look at dots. Or if you like, you can even ignore this. So this to say that we have so many intermediate offsets between 1 and 7. So in fact, we know that it's 4, 5, 6, I know that. We just find the lazy here. So we should use dots. I okay. Okay, so you get what was the challenge?
This we have this is the strips. We have
so these poles are offsets. The distance from here to here. So this O1. So this O1 is actually equal to maybe some kind of this the reality. Okay. And this is the ground. We are long. Okay. We're trying to work out of it. So we just draw a long line like that. This line like that. Okay. Then we do offsets along it. Then we take offsets to the shape. Okay. The shape is looking funny. And we still take the offsets there. Okay. Okay, are we ready? So, okay, how many strips do we need? What determines the strips? It is to the class. Then let's have an interactive class. What determines the number of strips?
the offset distance of the area.
Say again.
The offset distance can also determine the amount.
Let me start. I said something. How many strips do we have? What determines it? You're not listening. I think you are still in the new year. Christmas is not gone. Okay, if you have an odd number of offsets, so a number of offsets is equal to number of strips minus 1. Let's take a typical simple case like 2 strips, 3 offsets. I agree. So let's say 2 more strips. 2 strips. Okay. Offsets. So it's not correct. So remember, I want you to write a relationship. You are the students. It's so simple. I want you to break up on your responses. So, okay. What's the relationship between number of offsets and number of strips? So here, how many strips? How many offsets? So number of strips plus 1. Is that not so? I have 7 offsets. How many strips do I have? 6. I have 6 strips.
Yes.
Isn't it? Okay. Is 6 an odd or even number? So if you are giving someone this formula, what should you be telling the person? That it should be, you should make sure that you always have an even number of students. And that's what I started this on when I started. Are you okay? I mentioned that that's the assumption. Are you okay? That's the first assumption. Are we on the same page? The formula is nothing. We can put numbers in it. But if you don't understand it, so my work here. Okay, now we can generalize this by taking the 2 in there, take 2 in there, and then we actually have x into 1 plus the last one divided by 2 plus, and then the intermediate ones O2 plus O3, O2 plus O3 all the way to O(n) minus 1. Where n is, what's n? Maxwell, your name always comes to mind. Even Christ is here, but your name is the one that's always comes. Yes, Said. What is n? Tell your lecturer, someone that a novice, someone who meets outside. What is n? Our lecturer gives us formula. I'm going to tell what n is. What's n? Is
The number of offsets.
the number of offsets. Like, all right. So the 7th offset. So you can look at this formula to understand this better. Okay. Okay, so here n minus 1 is like 7, isn't it? It's not correct. Yeah, it's not correct. It's not correct because n minus 1 is 7. So n minus 1 equals 7 is telling us something. That the 7th offset is determined by the number of strips. The number of strips formula is actually number of offsets minus 1. The number of offsets, isn't it?
6.
Okay. So what is n? What is 7 in this formula? Is the last offset. How many strips are you doing?
6.
So offsets, so we get 7, right? Equals number of strips. Is that also?
Yes.
Number of strips equals to 7 minus 1. Yeah? Number of strips. So number of strips is offset. No, don't get confused. It's all right. It's like play with it. Some of these things so simple, you can just get it. It's okay. So Said, are you on the same page? All right. So that's it. You can just use it to solve any. So you force the figure, even the figure is not having the number of strips in it. If you are given any question, then you need to force the strips to what? Even. Or just assume. So if I do this, okay, just assume that it's about like, it's of 1, 2, 3, 4 people, right? If you do this, 1, 2, 3, 4, 5, that's a problem, isn't it? I mean, you use something, right? So you do it touching that. Okay. All righty. So here there's a question. The offsets we've been given O1 to O10. Is there a problem with it? Yes, class. O1 to O10. Is there a problem with the offsets? Should the offsets be even or odd? It should be odd. Okay, so O1 to O10, how many offsets?
10.
What should we do? Again. Oh, we can hear you. From where? So we can assume that there is an offset which is 0. What about that? You see that trick work? So instead of having an even number, you get what I'm saying? We just okay, so it's very important that we just play with that even and odd thing. Get it. Let's move on. We have a lot to talk about. That's it. I won't talk about this again. And we won't even work an example. You can just see an example in the book. Simpson's rule. Okay, Simpson's rule. We can touch on Simpson's rule. with Simpson's rule, the formula is similar to the other one. So you can look at it. Please write it down. Just look at Simpson's rule. Okay. Very simple. X over 3, x plus 2o plus 4e. Okay, let me write it down. Let's quickly look at it and see. Similar to this one, just the interpretation. Says that the area is equal to x plus 3. Then we express the odd and even offsets. Okay. So x 2, 4, x 2, 4. Okay, if you want to remember it quickly. Okay, example x 2, 4. Okay. So what is x? X is the sum of first and last offsets. Okay, and we know what the offsets are, isn't it? Okay, O is sum of odd offsets. E is sum of even offsets. Sum of first and last offsets. So offsets. So when we say the first offset, O1, the first O7, I'm using the O7 offsets. O2 is an even offset. Result is an O3 is an odd offset. So when we are adding on the 2, 4, odd, now O3. Sum of even, oh, this is odd, isn't it? Sorry, even offset. Okay, so you simply look, if you have O5, you add O3, so this is O is equal to O3 plus O5. Okay, and then E is equal to O2 plus O4. Second offset plus the fourth offset gives you E in this formula. X is the interval. So it's similar to this one. These are the formula and written in a different way. So when you are asking questions like this in exam, it's quite tricky. You don't even know whether you are being wicked to the student or not. You know what I'm saying? Because you can just ask same situation and the student has forgotten it. It's rather remembering the trapezoidal rule. Okay, and we all know of the story of the guy who went to exam and he learned about rabbits. And when he went, the bird has come. And he started with the tree. Okay. And then he said that a rabbit lives in the hole under a tree, but on top of the tree is a bird. Therefore, bird. He started dissecting the bird, talking a lot about the bird. The bird is a species like this, blah blah. See, the person has deviated. But sorry, guys. Sometimes some subjects are courses are a bit on the harder side. Too many choices for one calculation. Right. Today in this world today, I'll just take my GPS, go and pick the coordinates, put it into GIS software, and calculate my area. Forget about all that I'm talking about in terms of area. With that triangle, I don't care. Do you get me? That's where we are in terms of the latest technology and knowledge. You don't have to like do it. But it's because we are in academia, we're doing all this like literature. We are studying what people have done in the past. Okay. Sometimes too, this is very practical. If I have an app on Play Store that uses these methods, coordinate method, trapezoidal, okay. So you can check it out. The coordinate one uses your GPS location on the phone. Okay. And it will give you the area. It's nothing complicated like we may want to look at it. Okay, so that's it. Yep. Given the question, whatever question you are asked, try to find a way around it. Figure out whether it's even. If it's not even, try and probably make it even. Are you get the strips? All right. Let's look at volumes. Why do you need to calculate volumes? Why do you need to calculate volume? As an engineer, why do you need to know the volume? We talked about it last time, but let's do it quickly. One sentence by someone, then we carry on.
For estimation.
For estimation, what's whether you are tired. Estimating what? To make estimates for your clients, isn't it? Okay, because most of the time, as a consultant, they need to always come up with some estimate. Tell us how much, isn't it? It's almost like the basic thing. Once you're able to do that, project starts. Are you okay? Right. So for estimation, what other purpose you need to know? Volumes. Someone gets employed, and a surveyor gets employed, and they say, we just interested in you calculating the volumes for us. Wow. Here's your car. Are you okay? Is that all they want me to do? So why do you think is important? We said in the last lecture that you are most of the time contractors are paid. Are you okay? Based on what? Most of the costs on site are is based on what the cubic meter that has been moved. Are you okay? So we just want to know how much cubic meter you worked on for the day. Are you with me? Then you get paid. So you just multiply the amount. Are you okay? $200 by so volume. What if the volume calculation goes wrong? Okay, intentionally we can make it wrong. Cutting corners. We don't do that. It's okay. We don't do that. So you need someone that you can trust to do this work, a professional that will calculate the volume and accurately. Is that okay? So volume calculation is very important for the quantities. Are you okay? Quantities, how much? And also, when you do every construction, you need to know that cuts and fills actually are the economic aspect of it. Are you okay? So if I left you to do some work and you didn't know about this very basic common sense approach that cut a part and fill another, are you okay? Then you will be, what would you do? If you were a little boy, what would you do? If you didn't know I have to cut some part. Oh guys, don't sleep on me, come on. Just have a check for pricing. It's Friday. Yes. Oh, what would you do? You see, let me tell you what. I said the time and again that when I was in first year, so many years ago, I remember I answered a question in the exam and I said my answer was that we should take just to just. And later when after some years I asked myself, how stupid was the answer? Take just to calculate something. No, but I'm telling the truth. I wrote it. And that's what I'm not meaning on you. Unless your answer is totally off. What would you do if you know about that? The natural thing to do would have been, so let me just draw this. In this small section. The ground, the topography looks like that, okay? And then here you are, you're the engineer. And they want you to construct a room, isn't it? How do I do this? Oh my God, my mother help me. Are you here? You are there scratching your head. How do you do it? What's your first thing? Let me just put all of you on the spot. We've learned about vertical curves, horizontal curves, and everything. And then you see this humongous topography. And you why God, why did you make the topography the F shape, something like that? But now I'm in trouble, isn't it? What would you do? Yes. Oh yes, you're a kid. You want to be a kid in this case. Why did we say he should be a kid? Or we finished that one? He still wants to be a kid. It's like level. Are you okay? Trust me, someone will do it. Say thank you very much. You are being honest, and I like you for that. You see, don't worry. Try. Are you okay? Try all this thing and then you'll be free. You see, we are all laughing, isn't it? What's the problem? By the time you finish, all the diesel in the company gone. All the diesel. How are you talking about? The approach you have to pay the bookings. Are you okay? The guy driving the operator. And operators, when they see this, they always have to. Are you okay? They see the guy has messed up. I will tell you. What's around this pickup? He thinks he's a man. That's it for him. He will wait till the day you are sacked. He will wait. And the day they will just be laughing. They know it. They know more than you. Because they've been working for 30 years, isn't it? You just got in there with your funny. Okay, so this is why you have to cut some parts plan. So literally, we do something looking more like fitting, just for a kid, like fitting a line in such a way that we can actually cut parts that are above the line, the design line. So this is a straight. This is a straight we're talking about. But this straight is actually sectional for a sectional view. Are you okay? All right. And then we want to just fill this part with this, and we still have some surplus. Is that okay? That so we need to actually calculate how much volume is being like moved, cut, how much is being, how much is being cut and how much is being what? How much is really being cut is what we need to fill other places, and how much fill we need to do. Are you okay? So our needs and what we have. All right. So yeah,
we also depend on the type of soil. If the soil is good for the field.
That's a good one. So this one is like going a level beyond this class. Is okay, because we all know that not a lot of soil support. Are you okay? The kind of construction that we want to do. So it depends on the type. So this one, if in next I'm able to calculate everything, finish, you just write down at the bottom for me. I'll just give you, if it's 10 marks, I'll give you 12 marks. Because you are giving me more. Are you okay? So let's better in it. Okay. So even though we are talking about this, this is something that in this class we are not even touching on. That we can't take clay and go and fill. Are you okay? For some kind of woodwork. Are you okay? It won't work for you. We want to take it out and then fill it with some other material carried from else. We'll talk about this. It's okay. Talk about this again right now. It's okay. All right. But what we need to calculate the volume is okay. The volume is very easy. It's very, very easy. Anybody can calculate volume. Almost everybody can, especially the markets, they are very. All right. You just take this one and then multiply it with that. That's the base, isn't it? So you get this area and then multiply by the height, isn't it? So you name this distance L2, this by this, and you build it up to this point, isn't it? Okay. So that's why we need to know the area calculation. But what means that once you know the area, you can calculate the. All right. So for most roads, we are looking at something like this. Okay, so the center line is somewhere in there. Okay. And then for basic, I'm trying to explain to you the basic in terms of calculating the volume. All right. You want to know this cross-sectional area, okay? And then simply multiply by this length. So A times L is the basic in terms of volume. So I can just close the class and say, this is it. I made my point. All of you go and now see the different ways you can end up. The challenge is that you don't have a straight line all the way from the beginning to the end. Okay. You may have the middle a bit going up a bit, going down. And you could also have curves in there, isn't it? So it gets a bit sophisticated. But the basic is to take the area, okay? And we are assuming that the area at this end, area here. So A1. So A1 is equal to H, A equals A1 equals H. when you do this kind of thing. Are you okay? That's what you are saying. Are you okay? All right. It may not be the case. May not be the case. When two may do, okay, anyone may be a bit greater than it to slightly not before but what would you want to do? Naturally, you want to find the mean, are you okay, of the areas and then multiply by the length. Okay, so you see there's an approximation going on there. All right. In fact, most of the things we do as engineers, there's always going to be a little plus or minus. So you can just do that, okay, and you end up with the volume. So to get it more accurately, then you do A1 plus A2 divided by 2. Are you getting? So this is actually volume by mean areas. Okay. So you find the mean. In other words, if you have more cross sections in there, you simply find the mean of them. Why the mean? Because mean is a statistical value. You know? It's kind of the true value. It approaches the true value. Is okay. So I show that. Okay, if you find the mean terms of this, you get something looking more like the correct cross section. All right. But anything that's subject to statistics is always not an idea. They're a good thing. All right. What am I talking about? Volume when I'm talking about cross-sectional areas. So let's touch on formulas for cross-sectional areas. So then we will come here. So I'm going to get ahead of myself. All right. We are going to look at how to compute the cross-sectional area. Why is that important? It's important because in a situation where you are actually failing, you feel like this. Have you seen a road being built or something? They've got a lot of soil, yeah, earth material on there. So it is almost above your house. Yeah. Are you okay? That's a little. Are you okay? So here we have some sort of embankment. Are you okay? Okay. So now when we do that, your center line goes to like so. Okay? Right? And then we want to calculate the record in this. Right? Don't worry about this. It's a formula. You can't calculate it easily like that. It just but I want to understand the shape. All right. Here we have a very regular symmetrical figure. Right? We have side slopes. So this is slope. So that one. The same slope as this here. Okay. All right. Then we have the side width W. We have W. So let's start with this. Be consistent with what I have in my notes. Okay, so the W and then half B or what's it? So this is a side width. So W represents side width and B so this is B. Okay, so B of plus B plus that's the right. So this is B. So side width. So W is called side width. Okay? Alright. But because it's symmetrical, we are fine. Okay. And then B of so same slope. This doesn't always exist, but this is where it starts from.